So, you know that feeling when you're staring down a massive, sprawling project? Maybe it's a tangled web of organizational rules, or just a really dense piece of software, and you just feel entirely paralyzed by how complex the whole thing is? We've all been there. That cognitive overload is exactly what we're going to conquer today. Welcome to this explainer. We're going to equip you with what's basically a cognitive Swiss Army knife. It was developed by Justin Kornhaus back in 2026, and it's called Dismantlement Theory. And look, this isn't just another buzzword framework. It's actually a really profound methodology for breaking down the absolute most baffling systems in our world and, actually making sense of them.
Okay, let's dive into this. According to Kornhaus, every single complex system you encounter is silently asking you one really profound question. And that question is, what generated me? It's not asking you to memorize every single moving part, right? It's asking you to find its origin, its underlying logic. When we face complexity, our absolute first instinct is usually to just start cataloging facts. But as we'll see, hoarding facts is definitely not the same thing as true understanding.
So, that means we really need to shift our paradigm, which brings us to the formal definition of dismantlement theory itself. It's a methodology that operates on a single, super powerful assumption that systems possess an underlying structure. Our goal here isn't merely to just reduce complexity, but to seriously increase our explanatory power. And we do this through three core actions: recursive decomposition, compression, and reconstruction. Now don't worry about the jargon. By the end of this explainer, you're going to know exactly how to apply each of these actions to uncover the hidden organization inside literally any system.
To get there, here is our roadmap. First up, confronting complex systems. Second, the engine of understanding. Third, the taxonomy of uncertainty. Fourth, reconstruction as proof. And finally, reorganizing our knowledge.
All right, let's kick things off with Section 1, Confronting Complex Systems and the Power of Structural Presumption. The very first step here is treating observable systems as if they have an underlying organization. And Kornhaus makes a really brilliant distinction here. This is not a belief. You don't have to blindly believe that the universe is just perfectly elegant. Rather, it's an investigative stance. You assume structure exists because, honestly, that is simply the most highly productive way to investigate whether it actually does exist in the first place. It gives you a solid starting point. And a really key part of taking that stance is recognizing that what looks like a totally chaotic mess is often highly compressible.
See, a lot of systems seem overwhelming just because they are expressed rather than explained. Think of a beautifully detailed painting, right? The expression is infinitely complex, but the explanation behind it might just boil down to a few specific brush techniques and color theories. And this is vital. Compression does not discard information. You aren't just dumbing things down. Compression discovers relationships. The better you can compress the information by finding those hidden invariants, the deeper your understanding actually is.
Moving right along to Section 2, the engine of understanding. We're going to look at recursion and methodology.
Okay, so here is the actual engine that drives this entire theory. We start by assuming structure exists. Then, we dismantle the system recursively. And what does recursive mean here? Well, it means every subsystem we find basically becomes its own new system to examine. It's a continuous loop. We identify repeating relationships, we separate the core truths from the random incidental details, and then we compress those observations into general principles. Next comes the real test. We actually try to reconstruct the original behavior based on our new principles. If our prediction fails against what we observe in the real world, we revise our model and run the loop all over again. You just keep peeling the layers until further decomposition stops giving you any new explanatory power.
Now, I want you to consider this carefully. The objective is not certainty. The objective is increasing explanatory power. And I know that is highly counterintuitive for a lot of us. We're trained in school to seek the one, absolute, perfectly certain right answer. But out in the real world with complex systems, absolute certainty is often a false goal. In fact, it might literally be unattainable. Resolution is very different from certainty. Your goal is simply to progressively build a foundation that explains more of the system today than you could yesterday.
That brings us to Section 3, the taxonomy of uncertainty. It's time to face the real villain of complexity. Kornhaus points out something fascinating here. Not all uncertainty is created equal. We have resolved uncertainty, which essentially turns into actual knowledge. We have open uncertainty, where we just happen to lack evidence, and that motivates us to investigate further. Then we have undiagnosed uncertainty, which is a massive opportunity just because nobody's even bothered to look yet. But now what's really interesting about this matrix is that final category down at the bottom, manufactured uncertainty. This is ambiguity that's been introduced completely unnecessarily. It just eats up our cognitive resources without producing a single drop of useful knowledge.
To make this perfectly clear, let's contrast them. On the left, we have legitimate uncertainty. This is honest. It's the limit of our tools, maybe computational boundaries, or simply incomplete evidence. But on the right, manufactured uncertainty. I mean, think about your own workplace, or even just daily life. How much of your confusion comes from poor communication, undocumented processes, shifting standards, or just arbitrary rules? That is artificial. It's bureaucratic waste, pure and simple. And dismantlement theory demands that we actively dismantle manufactured uncertainty.
Which brings us right to the principle of legitimate uncertainty. Uncertainty should possess provenance. Now, provenance just means an origin or a record. So what this essentially means is that every single unknown must have a clearly articulated explanation for why it remains unknown. Like, if you don't know something, you should be able to say, I don't know this because our measurement tools are limited. But if your answer is, well, I don't know this because the rules are totally inconsistent and literally nobody documented the procedure, guess what? You haven't found a limit of knowledge. You've just found artificial waste that desperately needs to be cleaned up.
All right, Section 4, Reconstruction as Proof. This is the ultimate test of understanding.
Listen, if there is absolutely one thing you take away from this explainer, let it be this dynamic right here. Dismantlement is analysis. Reassembly is synthesis. Taking things apart is entirely useless unless you actually possess the ability to put them back together again. Analysis alone is wildly insufficient. It's kind of like a mechanic taking an entire car engine apart, laying thousands of pieces all over the garage floor, and then claiming they understand the engine. No way. They don't understand it until they can rebuild the whole shebang and the car actually starts.
So a model demonstrates understanding only if it can reconstruct or predict the original system. You have to compare your prediction against observation. True understanding requires both of these complementary operations working in tandem. When you can take, say, a super complex software architecture, dismantle its logic, compress it down into core rules, and then successfully predict exactly how it will behave under a brand new load, wow, that is the ultimate, empowering validation of your knowledge.
And that brings us to our final section, Section 5, Reorganizing Our Knowledge, the Paradigm Shift in Epistemology.
First off, we really have to talk about failure, because this methodology wholly accepts it. Actually, scratch that. It embraces it. You will fail. Failure happens when you dismantle a system and you just get more and more details without actually gaining any explanatory power. All that tells you is that your starting assumptions were wrong, or maybe your observations were insufficient, your method of decomposition was flawed, or, in rare cases, you've hit genuinely irreducible complexity. But here is the crucial takeaway. Failure is diagnostic, not destructive. It's just feedback, not a dead end.
And you know, the true beauty of dismantlement theory is that it's entirely domain independent. Sure, it applies to mathematics and engineering, but it also applies to quality systems, organizational design, artificial intelligence, and even biological and social systems. Basically, wherever systems exist in your life, whether it's a tangled supply chain, a totally dysfunctional team dynamic, or just a massive data set, this tool can be applied to reveal the hidden structure underneath it all. This right here brings us to the ultimate paradigm shift. Knowledge is not accumulated. Knowledge is reorganized. Think about that for a second. Learning isn't about collecting a giant pile of disconnected facts and just hoping you can remember them all for the test. Learning consists of replacing many disconnected observations with fewer, much more powerful structures. The true measure of your understanding isn't how much raw information you've retained. It's the level of explanatory compression you've managed to achieve.
So as we wrap up this explainer, let's quickly review our guiding principles. When you face overwhelming complexity tomorrow, I want you to remember this. Do not seek certainty, seek structure. Do not try to magically eliminate all uncertainty. Resolve the legitimate unknowns and ruthlessly dismantle the manufactured artificial ambiguity. Do not memorize complexity, compress it into its core relationships. And finally, do not merely analyze. Understand the system sufficiently so that you can actually reconstruct it.
Which brings us all the way back to the very first question every system asks us. What generated me?
Justin Kornhaus leaves us with this absolutely incredible thought to summarize the whole journey. He says, "Understanding is therefore not the accumulation of knowledge. It is the recursive dismantlement of complexity until explanation becomes simpler than observation." I love that. The next time you feel completely overwhelmed by a system, just remember that you already have the tools to dismantle it. So what complex system in your life is waiting to be dismantled right now? Thanks for joining me on this explainer, and I absolutely can't wait to see what hidden structures you uncover.